Quick little screencast for the Endocrine physioEx. I thought I would put myself down there in the corner for a change, just because, why not? I can do it, and there's room on the screen. So this is the sheet that I initially gave everybody, and I decided I don't like it. So I created this with an old sheet that I forgot I had and liberated from a PDF. So now we have this in Word. I will post, what was I going to say? I have filled this out and will post a version of this with nice typed in answers if you want this to help organize your thoughts and the data from the Endocrine physioEx. But we're going to cover the same questions that are in the sheet. It's just this visually, I think, makes it easier to organize. So the first thing it asks you in your sheet is which rat had the fastest metabolic rate. So we need to establish what the metabolic rates were. And, I'm having a hard time writing. I'm just going to write in some numbers here off the top of my head. I think they're like 1900, 1700, and 1700. And it doesn't really matter what they are, because on the exam or a quiz, I'm never going to ask you for the values. I'm going to ask you which rat had higher or lower metabolic rate. So the first thing you want to be able to answer based on just this first row is who had the highest metabolic rate, which is the normal rat. Then the follow-up question is why? Right? And the answer to that is the normal rat is not missing anything. The thyroid ectomized rat is missing its thyroid, which produces thyroid hormone, which stimulates your metabolism. So if you don't have a thyroid gland, you're going to have low thyroid hormone levels, and your metabolism is going to be lower. Hopefully you already know all this because you went through the lecture PowerPoints, but we'll cover it anyways. Then the hypophysioectomized rat, hopefully you will know, is missing its pituitary, which the Greeks called the hypophysis, and that's why it's called the hypophysioectomy, because we still have this leftover Greek term in our, I don't know if it's leftover, it's just a Greek term. So some people call the pituitary the hypophysis, so a hypophysioectomized rat lacks the pituitary, which means it can't make TSH, which means it is functionally without a thyroid. So its metabolism is at the same level as the rat that doesn't even have a thyroid. Then for the rest of the table, all you want to know is if the injection is raising, lowering, or not changing the metabolic rate in the rat. So now we're comparing all of the rats below to themselves in their own baseline reading. So if we inject a normal rat with thyroxine, what can we expect to happen to its metabolic rate? Given what we know about thyroid hormone, that should go up. Then the thyroid ectomized rat also goes up, right? So, and again, it doesn't matter what the value is, just know that it goes up. And then here as well, if you take a rat that doesn't have a pituitary and you just inject it with thyroid hormone, the levels should go up. And if when you did this, the levels down here went up to this level here, up to like hyperthyroid levels, it's supposed to happen that way. It's what happens when you inject a rat with a day's worth of hormone all in one shot. You get elevated hormone levels and elevated metabolic rate. So that's all straightforward. Their metabolic rate goes up because thyroid hormone stimulates your metabolism. Then we get down to TSH. So we hit a normal rat with TSH. That should cause up, down, or the same. Hopefully you're all thinking up, or hopefully you all remember up, right? So this is going to elevate the thyroid hormone levels above normal, so the metabolism is going to go above normal. I just realized I made a mistake, but it doesn't matter. I think it's supposed to be 1700 is normal, 1500 is low, and then when you give them the injection, they go up to 1900 above normal. But again, we don't care about values, so I didn't even need to say it, but I had to. So next up, we take our thyroidectomized rat and we inject that with thyroid-stimulating hormone. Should the metabolic rate be higher, lower, or the same than its baseline? It should be the same. I'll just draw a horizontal line there, right? It doesn't have a thyroid, so you can inject it with thyroid-stimulating hormone. And if there isn't a thyroid to stimulate, nothing is going to happen. So that rat's metabolic rate will stay low as it was in its baseline reading. Then you take the hypophysioectomized rat and inject it with TSH, and you should have seen an increase here. So you're basically giving this rat back the hormone that it was missing, and the missing TSH stimulates the thyroid that is there. You get an elevation of thyroid hormone levels and elevation of the metabolic rate. Then you were supposed to look up what propethiouracil does. I don't know if you all did or not, but it is an anti-thyroid medication. It prevents the synthesis of thyroid hormone. So it doesn't block its action, it actually blocks its synthesis right at the root. So if you take a normal rat and you hit it with PTU, now we should see a reduction, because you are inhibiting this normal rat's ability to make thyroid hormone. Its thyroid hormone levels will go down, its metabolism will go down. So then you take your thyroidectomized rat and you hit it with propethiouracil, say that 5 times fast. And will its metabolic rate go up, down, or stay the same? Hopefully you're thinking stay the same, right? Its metabolic rate is already as low as it's going to go. It is without a thyroid gland, so it is without thyroid hormone, so you can inject it with thyroid hormone inhibiting drugs and it's not going to have an effect. And then the same thing here, we should see no change in the hypophysioectomized rat, because without TSH, the rat is effectively without a thyroid. It is not functioning at all. So those are the questions that you want to be able to answer. In the first line there, which rat has the highest metabolic rate and why? And then in the other 3, what effect will the injection have on this rat and why? That's it. Pretty straightforward. And that's it.